Hi, this is Jaru. Now I'm going to do the second question of homework 2. So in the second question, we will see there are many noise channels, and when the first channel is, when the last channel is 0, the possibility of current channel to be 0 is 0.6, and when the last channel is 0, the possibility of the current channel to be 1 is 0.4. When the last channel is 1, the possibility of current channel to be 0 is 0.3, and when the last channel is 1, the possibility of the current channel to be 1 is 0.7. Okay, the first question is what is the possibility of the second channel to be 1? We all know that the possibility of the second channel to be 1 equals to the possibility of the second channel to be 1 when the first channel is 0, multiplied by the possibility of the first channel to be 0 plus the possibility of the second channel to be 1 when the first channel is 1, and multiplied by the first channel to be 1. So as we all know that because the possibility of the first channel to be 0 equals to 0.2, and the possibility of the second channel to be 1 when the first channel is 0, the possibility is, let me see, it's 0.4, right? And when the possibility of the first channel to be 1 is 0.8, and the possibility of the first channel to be 1 when the first channel is 1 is 0.7, so it's 0.08 multiplied by 0.56, which equals to 0.64. Okay, and the second question, in question B, we need to find out the possibility of the third channel to be 1. It's very similar to the second question, but a little bit more complex, because the as we said above, the third channel to be 1 equals to the first channel. The third channel to be 1 when the first channel is 0, multiplied by the possibility of the first channel to be 0 plus the third channel to be 1 when the second channel is 1, multiplied by the possibility of the second channel to be 1. And because we do not know the possibility of the of the second channel to be 0, in fact we already know that in the first question, so we can use that directly. So let's see, the possibility of the third channel to be 1 when the second channel is 0. The possibility is let me see, 0.4, right? And the possibility of the second channel to be 0 is 0.36, right? And the possibility of the third channel to be 1 and the second channel to be 1 is 0.7 multiplied by the second channel to be 1, which is 0.64. So this equals to let me see, this equals to 0.592. Okay. So let's look at the question C. The question C wants us to find out the possibility of the first to be 0 when the 3 is 1. I mean, because we already know that this possibility equals to the possibility of the first to be 0 and the third to be 1, and divided by the possibility of the third to be 1, which equals to the possibility of the 3 to be 1 when the first to be 0 multiplied by the possibility of the first to be 0 divided by the possibility of third to be 1. So that because we already know the possibility of the third to be 1, and we already know the possibility of the first to be 0, and let me see. And because we already so for the third to be 1, the first to be 0, and this possibility equals to, let me see, possibility equals to because third to be 1 and the first to be 0, I mean it's and because we already know that when the x1 equals to, we already know that when x let me see how to calculate. So when the first is 0, we can know that when the second is, the possibility of the second to be 0 and the possibility of the second to be 1. And the let me see what is the two possibility. The first one, this one is 0.6 and this one is 0.4, and because we already know that the possibility of the third to be 1 when the second is 0 is 0.4, and the possibility of the third to be 1 when the second is 1 equals to this possibility equals to 0.7, so that the possibility of the third to be 1 when the first is 0 equals to the possibility of the second to be 0 when the first to be 0 multiplied by the possibility of the third to be 1 when the second is 0 plus the possibility of the second to be 1, first to be 0 multiplied by the possibility of the third to be 1, the second to be 1. Okay, so the answer is 0.6 multiplied by 0.4 plus it's 0.4 multiplied by 0.7, which is okay, that's it. So that we can know that the possibility of the third to be the possibility of first to be 1 when the first to be 0 when the third is 1 equals to 0.52 multiplied by 0.2 divided by 0.592. Okay, and this equals to 13 of 17.4 approximately x to 1.76. Okay. For the last question, we need to know that the possibility of the nth noise channel to be 0 when the n is approaching infinity, positive infinity. So we can see from the above questions, and we can, find a rule that, the way that we calculate the second question, the first question, second question, third question is very similar. Actually, we need to use the matrix to notate it so we can see it more clearly. So basically, the answer is the answer of the formula is the answer of the question. So because we can calculate that the value of the matrix is equals to 3 of 7 and 4 of 7. So we can know that when the n equals to positive infinity, the answer will be 3 of 7.